Hello students, welcome back. We're going to work on absolute value inequalities today, which is a continuation of our lesson yesterday on absolute value equations. First of all, we have to remember there's a difference between solving equations and inequalities, and it's only one difference. When we solve a linear inequality, we solve it just like we solve a linear equation, except that when we divide or multiply by a negative number, we have to flip the inequality. Hope you remember doing that from earlier this year. Alright, so we're going to use this along with what we learned about absolute value equations yesterday to find the solutions to absolute value inequalities today. Alright, so our first example, get my pen right, says the absolute value of 2x plus 3 is less than or equal to 7. If you'll remember from yesterday, when to get rid of the absolute value bars, we have to write two equations, or in this case it's going to be two inequalities. One of them is positive and one's negative. So I'm going to write 2x plus 3 is less than or equal to 7. And I'm going to write the negative of that, 2x plus 3, is less than or equal to 7. And then I'll solve each one of them. By subtracting 3, get 2x is less than or equal to 4, then divide by 2 and get x is less than or equal to 2. The second one, remember when I have that negative out in front, that's like I'm multiplying by negative 1. So I want to divide both sides by negative 1, or I could have distributed if I wanted to. But those negative 1's cancel, and I'm left with 2x plus 3 on that side. And now, since I divided by negative, my inequality is going to flip to greater than or equal to, and I have negative 7. Then we'll solve this one just like we did the last one. I get negative 10 this time. And when I divide by 2, I'm going to get x is greater than or equal to negative 5. Now what I'm going to do is I'm going to graph these. X is less than or equal to 2. So since it's got the equal in it, I'm going to use my bar there. And actually I'm going to draw it up here first. And less than or equal to 2 is going to go that way. X is greater than or equal to negative 5. It's going to start there and it's going to go to the right. So I'm going to bring that down on the graph, and I'm going to shade where they have in common since they overlap. And there's where my solutions are. Now since it's greater than this and less than this, I'm going to write this as a compound inequality. And it's going to have less than or equal in it because the problem had less than or equal in it. The small number was negative 5 and the large number was 2. So I'm going to write it that way. So when I have a less than or equal, I'm going to write the solution as a compound, and this means and. It's an and statement. Okay? So that's when I have less than or equal to. Let's look at this situation when I have greater than or equal to. Alright, so here's our example. It is 2x minus 3. The absolute value of 2x minus 3 is greater than 5 this time. So I'm going to write it as two inequalities. 2x minus 3 is greater than 5. And I'm going to do the negative of that. 2x minus 3 is greater than 5 also. And then remember, I'm going to divide that by both sides by negative 1. And I'm going to get 2x minus 3 is less than negative 5. I had to flip that inequality because I divided by negative. Alright, now I'm going to add 3 to both sides, both equations. And get 2x is greater than 8. So x is greater than 4. I divided both sides by 2. Here I'm going to add 3. and get 2x is less than negative 2. When I divide by 2, I get x is less than negative 1. When I graph these, I'll graph 4. Now this doesn't have the equal, so I make it an open dot. X is greater than 4. Goes that way. X is less than negative 1. Again, it doesn't have the equal in it, so I draw an open dot. And if you'll notice, with the greater than, I have a space in between them and they go opposite directions. We call this an or statement. So this means x is greater than 4 or x is less than negative 1. And that's the way I write the greater than problems. And my graph is going to have a space in it and point opposite. If I put 2 in here, 2 times 2 is 4 minus 1. 4 minus 3 is 1. That's not, and the absolute value of 1 is 1. That's not greater than 5. That's why it's not there. But if I pick a point over in this area, over in this area, and plug them in, they will work. They will give you a correct solution. Okay? Alright, so let's summarize what we have. If we have an inequality that's less than or equal to, then the solution is going to be written in this format, where A and B are those solutions you get when you solve each of them. And then you're going to have a bar, like something that looks like a barbell, as your graph. And your solutions come from the inside of that. I've got this drawn with solid dots, so that would be like the equal. If it was did not have the equal in it, then those would be open dots. Okay. All right. The other part of our summary is if the inequality is greater than or equal to, then the solution is going to be written with an or statement, and your graph is going to have a gap in it, and the arrows are going to point off. And again, this is written with the equal in it because it has solid dots, but if it didn't have the equal, it would be open dots and go in those ways. Okay? All right. I hope this made sense for you. If there are any questions, go back and rewatch that part of the video, and make sure when you come to class tomorrow that you've completed the WISC, the WSQ document, and you are also prepared to answer any questions on this. We'll most likely also have a K-check on the absolute value equations. Okay? Have a great night. We'll see you tomorrow.